All right, so let's talk about data definition. So first, we're going to be talking about what we're going to be spending most of our time the first half of the semester of talking with about relational databases. We'll introduce tables, records, and foreign keys, primary keys, and whatnot, and it'll be the bread and butter for the next month and a half or so. So first, we'll talk about some of the raw low-level concepts of working with the relational databases, and then we'll backtrack a little bit and say, okay, well, we know what a table is, we know what records are, and we know fields and whatnot, but let's think about it a little more higher level, right? And we'll introduce UML in the next presentation. First, let's introduce the topic of interest for the first month or so, and let's talk about tables. So table is again, it's an abstraction of how we want to think about uh, um, data points that are somehow related to one another. And so just like a set in mathematics, right? A table would be a big bucket that would contain all the data points that are somehow related, are somehow similar to one another. So there'll be one bucket of students. There'll be a bucket of sections, a bucket of courses, and so all the data points that have the same attributes are somehow in the same bucket. Yes, and we call them tables. An instance or nugget of piece of information in any of these buckets, we call them a record, right? So it's a data point in this data table, and each record has presumably all records in a table have all the same attributes, right? So we're all students, we all have first name, we all have last names, we all have social security numbers because at some point you're going to be paying taxes. And each one of those fields will have a specific data type, whether it's a date, number, strings, and all sorts of different constraints. Um, and uh, and so we all live in the same table. Now we also mentioned that a database typically it will have multiple schemas, right? And that schema will contain many tables. But we loosely use the term schema. We overload the term and use it quite loosely. We also talk about tables having a schema, right? But in general, we mean schema as a structure, the structure of the database as as a collection of tables. But then a table itself also has a schema, meaning a structure of all the attributes or properties or fields that make up a table. So for instance, here a database might have a schema which contains these 5 tables, right? But each table might also have a schema, right? A structure where a student has, student name, graduating year, and major ID, and so on and so forth. Okay. So yeah, we use the term schema loosely, as a generic reference of meaning the structure of something. And so this is a nomenclature we're going to be using quite often throughout the semester, where we might say the table, the section table has the following fields, right? It has a section ID, course ID, professor, and year offered. Notice the bold and italic here. Those have meanings, and we'll talk about them in a minute. Whether they're primary keys, foreign keys, or both. So yeah, let's become familiar with those today and the next couple weeks. You'll find them again either in assignments or in quizzes. But I'll always provide a reminder of what the nomenclature means. Okay, no need to memorize it, but it'll be helpful. So this representation here, which is textual, might have a graphical representation and the various tables and data that might actually be stored. So these are the various buckets or tables. You have the student bucket, table, department enrollment section, and course. And you'll notice that there's some coloring here on some of the fields that are capturing some natural fields, right? Like the title of the course, the professor of the year offered, the graduating year, the student name, the department name. Those are all natural fields, right, that represent some physical phenomena in the real world, yes? But then you have other fields here that are not representative of anything in the real world. They're only used for internal purposes, right, for establishing that this data point is somehow related to that other data point, okay? And the way we do that is by these SIDs, major IDs, DIDs, EIDs, and whatnot, yes? So these 22 and 11 here somehow are referencing those 11 and 22 on that other table. And those 1, 2, 3, and 2, 3, 4 are somehow related to those 1, 2, 3, and 2, 3, 4 on that side, okay? And this might be by convention, right? It's just that we set up the convention saying that, hey, this value here, right, if it has the same value of that other field in that other table, by convention, we understand that these are related, yes? And I guess that would be enough. Other than obviously things might go wrong, right? What if I somehow change these values and I don't know what I'm doing, and that value actually had a meaning, right? That it was referring to something over there. So perhaps I shouldn't do that, right? So the database, for instance, allows us to enforce certain rules, right? That for instance, it would make no sense if I have only those two departments, chemistry and math, and I only have those two values, 1, 2, 3, and 2, 3, 4. It would make no sense to have a record in the student record where that major ID would be 3, 4, 5, right? If this were only by convention, nobody would stop me from doing that. Yes? But if instead I tell the database, hey, database, right, the 1, 2, 3, and 2, 3, 4 over there, those are primary keys. Okay? And the database says, okay, thank you. Right? So that means that I'm going to enforce certain rules. Right? That primary key cannot have all the values there need to be unique. Right? Because it's first is a key. It's a key, right? It uniquely identifies every record, and then it's primary, meaning it means that it's going to participate in a relationship, right? It means that somebody is going to be pointing to it, somebody's going to be referring to it, right? And I'm going to enforce certain rules, right? If anybody references a record here, right, that doesn't exist, I'm not going to allow it. I'm going to fail it, right? I'm going to report that somebody tried to reference a record in this database, in this table, right, that does not exist. We'll call that later on called referential integrity, right? The database will enforce certain rules that don't allow you to put bad data in here, okay? It would not allow me, for instance, to insert a record with Alice majoring in 3, 4, 5. Right? It would fail it. It says, no, you can't insert that because there is no 3, 4, 5. Make sense? Anyway, we'll come back to it in a minute. Also, notice that we've gone ahead and decided to split up the data, our data, into these 5 tables, and that might look somewhat arbitrary. Why 5 tables? Why not 4? Why not 3? Why not just one? One big table. Put everything in one big table, right? And put all the students in a couple of columns, and the course and the majors in one and another one, and their grades later, and the courses and the sections. Why not one big table? If we would have done that, right, and very naively perhaps might have done it just one big spreadsheet, yes, and started filling out the fields, we might have noticed that we have lots and lots of repeating information, right, of thermodynamics being repeated over and over and over, and the professor and the year and the department name, right? And again, this is what we'll come back to later, often, and we'll drill into you quite often, is that this is the kind of thing we want to avoid, of redundant data, right? If I allow this, I'm introducing a risk of me maybe misspelling this somehow, right? It's a very long word, and nobody might be validating that, okay? it's not because I intentionally did it. It could be just a very honest mistake, and nobody would have caught it. And where conceptually these are supposed to be all the same, right? And these are all supposed to be three supposed to be calculus. Well, how do I enforce that? Well, one of the ways that we can enforce that is by splitting it and say, no, 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 let's not repeat this 3 or 4 times. Let's have the information about the department all recorded only once, right? There'll be the department recorded only once, the course, whatnot, only recorded once. And that's how we decided, perhaps came to the enlightened decision to split this into 4 different tables, right? So going from here to here, we'll call that we're normalizing the database, okay? And there's a whole set of skills on how do you decide, how do you split these tables, right? And there's certain decision making on certain things that you want to avoid, and we'll say that there's first normal form, second, third normal form, and whatnot, right? And what kind of redundancy do they try to avoid? Right? There's all sorts of nuances on how to do that. So we'll talk about that a little later. Also, the concept of null values, where they represent the lack of information, meaning what is the value of this particular field? The value is that I don't know the value, right? It's not 0, it's not empty string, right? It's not space, it's not tab, it's not a white space. It's just I don't know, right? And because it's I don't know, it has a lot of implications on how you count records, or how do you compare records, right? Or how do you make certain decisions of asking whether this is the same as that, right? And null means I don't know how to compare these things. I can't count this. So it has certain implications on how records should be considered when the values is unknown. So be careful on when you're counting certain things that might be nullable. Keys, again, lots of concepts, a lot of jargon that we're going to be using throughout the semester. We need to be able to uniquely identify one record from another record, right? And and depending on the scope of our data set, certain things might be redundant or not, right? Perhaps in this room, I might be the only one called Jose. Anybody else called Jose? Right? By our sampling, I might decide that perhaps a first name is enough to make us unique in this room, and maybe it's true. I don't know. Probably not. But after a sampling, I might see that perhaps the first name is not enough, and I might decide that perhaps a combination of first name and last name, perhaps that might make us unique. Maybe in this room or not. Maybe not in the building, but yes, maybe in this room. Okay, and one of the flaws that I'm using deciding whether something makes me unique or not is the sampling, right? Looking at the data, and from the data trying to decide whether certain fields are unique or not, or combinations of fields are unique enough. Trying to discern it from a data sample, right? And we should not do that, right? The data sample, it can always be flawed, as you grow your scope, right? From this room from this building, for the university, for the city, the country, right? The planet, and eventually Mars, I guess, when Elon Musk gets us there. So the scope can always grow and make it false that whatever fields you chose is unique enough, right? So it should not be the sampling; it should be the intent or the meaning of the field, right? And since science has tries to convince us that there is no meaning in life, that nothing really makes us unique, we tend to come up with these random numbers, right? We come up with these student IDs or social security numbers or credit cards or phone numbers, right? That are just random numbers, right? That are meaningless, other than whatever meaning we attach to them, right? So usually, since it's often very hard to come up with a combination of things that make us unique, we often just come up with some random number that we can somehow guarantee within some scope or range that is unique enough within the scope that we choose, right? And presumably, for instance, domain names or emails is unique enough. Again, up until we broaden the scope and add a planet, then we have to add, dot Mars or dot Earth or something to know, which, well, where, what, or maybe we could just say it can have its own country code. Anyway, so keys is what allows us to decide which fields, make us unique enough, and or combination of fields. Now, some fields might not make us any more unique. Okay, that perhaps there's a subset of fields that is enough to make us unique. That if I add additional fields, that it wouldn't make us any more unique. Maybe my phone number in this planet is enough to make me unique. Right? That if I add my last name, it doesn't make me any more unique. Right? So oftentimes we call those additional fields, we call them superfluous. You don't need that to make you any more unique. So we call a key or super key that doesn't have any superfluous keys. We just call it the key. Okay. Selecting keys, obviously, is something that we know it's not going to be a duplicate. Ideally, it would be something that can be mapped to something physical in the real world, like a first name, a last name, an email. But oftentimes we can't. We can't guarantee the uniqueness, and we fall back on just a random number. But ideally, we can use some natural fields and what the intent is. An email perhaps is still unique enough. Other times, these keys or combination of fields we might use to set or enforce certain restrictions or certain constraints, right? That we might not want to allow a student perhaps to enroll in a section more than once, right? So even though it might not make it any more unique, it actually can be used to enforce certain rules, some business rules, where you might say, well, it makes no sense for the student to be enrolled in the same section more than once. So you could enforce that by selecting, for instance, a combination of fields such as student ID and section ID, and the combination is unique. So there's no way that the database will allow you to insert data where the combination is duplicate, right? So it's very, very, very common to use these keys to enforce certain business rules. For instance, here's a couple of other examples where a professor can't teach a course more than once a year, whatever, or that a course can't be offered more than once a year, or the combinations of course ID, professor, and a year, right? That enforces other business rules, right? And all these business rules typically are from having done a use case analysis, right? Having met with a client, and and written down all these requirements, and identifying what can be enforced at the database level. There might be certain things that can't be enforced at the database layer and need to be enforced at the application level, right? And that also is part of the architecture and designing of these data sets. Just a couple examples on the certain values, just to give it a concrete representation of what it would mean to do some combinations of values that are unique or break some of these rules. Duplicate records. Now, by default, some relational database vendors won't enforce that records can be duplicate. It'll go ahead and let you insert data that is duplicate. And what we mean by duplicate is that the data that you've inserted into a database, have actually exactly the same values, in 2, 3, 4 records. Yes. Oh, I'm sorry. Relational database management systems, the system that allows you to interact with the database. So it's a combination of the database itself plus any client that allows you to interact with that database, and enforces all these constraints and all the caching and all the optimization. I'm sorry. No, the database system that you download, MySQL, when you download and running it on your server, the database system, and we'll do that today, installing MySQL. Yeah, 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 the database itself. Yeah, running as a server on your machine. Yeah. What was I saying? Right. So it might be that you have 2, 3 records that have identical values for first name, last name, and whatnot, and the database truly can't tell them apart, right? If you do a query of giving me, give me a record whose first name and last name is so and so, it says, well, there's 3 records that meet that criteria, or maybe I want to change the grade of so and so. This is, wait a minute, there's 3 records that meet that criteria. You want to change all 3? Or I want to delete those that meet this first name and last name. It says, wait a minute, you want to delete all 3 records? I can't tell them apart. There's nothing that makes them any unique. So typically we would want to enforce the uniqueness of these records, and typically we'll do it through primary keys or some kind of key that enforces uniqueness on one of the fields. Primary keys, as I had introduced earlier, is a key, first of all, meaning enforces uniqueness, right? So the values in that field cannot be, 2 records cannot have the same value. So that's one of the constraints. Yes. A super key is just a combination of fields together that make you unique. But there might be some fields in there that are superfluous, that don't make you any more unique. If you remove those from the super key, you just get what we refer to as just a plain key. Yeah. So a key is a super key that doesn't have any superfluous fields. So we had mentioned a primary key. First of all, it's a key, right? That makes you unique. Presumably, no superfluous fields in there. But also died.